Alright guys, welcome back to week 9, and today we get to talk about either your most favorite thing from Algebra 2 or your most hated thing. It's really nowhere in between. We're talking about logarithms today. So why use logarithms, right? If you don't remember from last year, if you never really understood why you were doing them last year, pretty much the idea is that they exist to help you solve a problem like the following. So everybody knows how to solve something like this, hopefully, right? Like 3 to some power equals 9. Well, we can do that in our heads, and it's easy to see that, x would be 2, right? We just plug that in. Logs exist for the following problem. What if I change that 9 to a 19 instead? So 3 raised to some power is equal to 19. Well, I don't know about you, but I can't figure that out in my head. I know the answer is somewhere between 2 and 3 because 3 squared is 9 and 3 cubed is 27. So it's somewhere between 2 and a 3, but we'd be playing the guessing game all day long if logs did not exist to help us solve it. So this is going to be a refresher on how to go between the two worlds, exponential and logarithmic, and then how to solve a problem. Before we get into the notes down here, one other thing to remember is on your calculator, when you see the log button, be very careful with that. Remember that your calculator, if you just hit log, is always working in an invisible base 10, and it's not written there, but please don't use that button unless you know that you have base 10 going on. The other thing is the natural log button. If you don't remember, natural log has an invisible base E, and the reason here is because those are inverses of each other. It's kind of cool, and we'll talk more about inverses if you come to the tutorial, but it's a little too well, it's a little too boring to talk about right now. So let's go ahead and start solving some problems. All right, so first let's work on rewriting between the worlds of exponential and logarithms, okay? So I like to do a generic formula first, so that if I know I have a base raised to a power equals some generic number. So I just used A, B, and C just to be kind of generic. If I want to rewrite that as a log, it's going to be log base A of C equals B. So keep in mind, these numbers went to different places, okay? This base stayed a base over here, but these two switched places, and so that's just something that I know you memorized last year, but you may have forgotten, so I wanted to review it. So what would this look like if we put it into practice? Well, what if I had like 1 over x raised to the p power equals s. Okay, if you were told to rearrange this, which I understand these are all variables and it makes no sense, but that's kind of the point here. We're not looking for a number answer, we're just looking to rearrange. If you needed to rewrite that, it would be log base all of this, so 1 over x, of s equals p. So your exponent always goes to sort of the solution. It's the other side of the equal, okay? So rewriting exponentially is the same dang thing backwards, right? So I don't even want to rewrite the rule. It's just go backwards now, okay? So that if you're given log base 2 of r equals y. Okay, something like that. If you're given this, it just means work backwards. So the base that's on the log is the base of the exponent, and then these two guys switch places. So your exponent is now y, and your r moves across the equal. So that would be a review or refresher on how to rearrange, and then we'll just start solving problems. So let me give you a couple of examples. Let's say you were given, like, I don't know, log base 2 of 8. Okay, if you need to solve log base 2 of 8, what my brain always does is it fills in this missing equals, okay? Like, this equals something, right? So in my brain, I'm doing this. I'm going, well, it equals something that I don't know, and then I rearrange it in my mind. 2 to the x equals 8. And I solve it that way because this makes much more sense to me. So 2 to some power is 8. Oh, okay, well that power is 3. So I like doing it that way. Another one that, a little trickier, but just for some extra practice. What if it was like log base 4 and then like 1/64th? Okay, so what I would do in a problem like this is the same thing. I'm like, ooh, this equals something. So I'd be like, it equals something I don't know. Then I would rearrange. Okay, so how does that rearrange? The base is 4 raised to the x power, and it's equal to this fraction. So everybody just kind of moves into different places according to this rule right here. Okay, now what? Now I look at the 4 and the 64, and I think, okay, well, 4 to what power is 64? Well, 4 squared is 16. 4 to the third is 64. But what would make the answer go into the denominator of a fraction? The only thing that I know that does that is a negative exponent. So I'm guessing x is -3, right? Because if it's a negative exponent, you just do the math and then shove it to the bottom. So that's probably what's happening there. So beyond that, is it going to get a little more difficult? Well, sure it is. We're going to be able to... And by the way, honestly, you know what? Let's come back up here real quick, because now that we've talked through this, let's actually solve this problem out. We can't do it in our head, and we looked here and we know the answer is somewhere between a 2 and a 3, but let's find out exactly where it is. Now, if you don't have a calculator, now would be the time to grab the calculator, okay? And what we're going to do is come back up here and let's see, it's going to be like... Okay, I'm going to rewrite this. So it's going to be log base 3 of 19 equals x. And believe it or not, this really did just help us out a lot. I mean, I know you're thinking that didn't do a lot for me. It actually did do a lot for you, because now we can type this in the calculator. Now, as far as typing this in the calculator, okay, so like if you're don't remember how to do that, you have two options. On your calculator, there is a, under Math, you can find a log base button, and it will do it for you. Or, if you remember, there's a thing called the change of base formula. And on the change of base formula, what you do is you take whatever's here originally, and you just type it in as log of the second number, 19, divided by the log of the base. So that is going to give you the answer in the calculator. It's what it does is it changes your problem to a base 10 so that you can just type it in, and just make sure you close that parenthesis when you do it. So let me work on mine right now. I'm doing log of, what is that, a 19? Okay, divided by log of 3. And I got something wrong because I typed it in wrong. All right, we should all be typing in now. 2.68, and there we go. So 2.68 is rounded, of course, but that's the answer to a problem like that. Okay, now let's go down and see, can it get any trickier? Well, the only way it gets trickier is if you're forced to use the properties of logs, which there's only 3. These were rules that you'll probably remember as soon as I write them. Anytime you see 2 logs that have the same base, so log base A and base A here, if they're being added together, you can actually suck those together with multiplication. You remember this? Most people do. That once I write it, they're like, oh yeah, I remember that. And remember that if it's a subtraction in the middle, okay, how are those supposed to come together? Well, if addition is multiplication, then subtraction would be just the opposite, right? So it would be division. So those are your first 2 rules. And the last rule nobody ever remembers until I write it, and that's okay. The last rule was the whole, let's say that you have a coefficient in the front. And then it's like log base, B of C. I don't know. Let's say it looks something like this, and there's like a coefficient, and you don't like it, and you don't know what to do with it. Okay, that coefficient can go up as the exponent. So that's a real nifty trick. So whenever you're asked to condense an expression, condensing would mean the goal is for it to look like this side of the table. Okay, so these are the condensed. Okay, please condense. And if you're asked to expand, then the goal is to make it look like this side of the table over here. Okay, so for this next one, if I give you one and it says, hey, you know, use the properties to condense the following, you may see something like this. 1/2 log of 3x plus log of x over 5, and then maybe it's like minus log of, you know, y. I don't know. Okay, so I didn't write a base in on these, which is fine. It just means that's base 10, base 10, and base 10. So all the bases are the same. So we just start working off these rules, you know, backwards. So it's giving you this. No, it's not. It's giving you this, and you're trying to turn it into that. Okay, so the first thing I like to do is coefficient. So a coefficient of 1/2 does mean it's now the exponent. So this whole thing is to the 1/2 power. Notice my use of parentheses. Plus, now this one is a coefficient also because there's an invisible 1 here. And so if you've got a 1/5 here, you can just pull that out to the front as a 1/5. So that means the exponent on that x is a 1/5. And then we've got minus log of y. So that would be my first step, is the whole coefficient goes to the exponent. After that, I just look through and I'm like, okay, are these positive or negative? If it's positive, they're going to be multiplication, and they're going to be in the numerator. If it's negative, it's a division, therefore it's in the denominator. So I know that I'm going to pull this together, and these two are going to go on the top, and the y is going to go on the bottom. Now, if there's any simplification that can be done beyond this, please do so. Like, I'm totally looking at these two x's. This is x to the 1/2, and this is x to the 1/5. Well, what is the rule when your exponents are side by side like that? Well, the rule is to add your exponents. So I would probably simplify this in the following manner. I would do 3 to the 1/2, which 3 to the 1/2, if we'll write it like that, 3 to the 1/2, and then x to the, okay, now I need to add these fractions. So common denominator 10, so 7/10, and then all over y. And that would be like how I write my final answer, okay? All right, so use the properties to expand an expression. So now you're going to be given some nonsense like the following. Log base 3, and it might be like 4 square root of xy cubed. Okay, say it's something like that. Okay, if you're given this and you're asked to expand, now we work backwards. So I usually do I do the separating first, and then I deal with coefficients. Okay, so the first thing is you've got 4 times all of this. Okay, well, if it's 4 times all of that, when you break that up, it's going to be addition. Now, I'm going to go ahead with this square root. Y'all might remember that if something is a square root right here, that is the same thing as being to the 1/2 power. I'm actually going to go ahead and do that. And the reason I'm going to go ahead and do that is because if I leave that as a square root, it's not going to make much sense, and I won't have a rule for it up here. So just remember, a square root is the same as the 1/2 power. And now what? Now I'm going to break this up. So I'm going to recopy this guy. Okay, plus, now how do I break them up? Well, they're multiplied, so they're going to break up with addition. Notice I'm distributing. Notice I'm distributing that 1/2 to both of them as I break it up with addition. And now if there are any exponents, they need to come to the front. So no exponent here, so we just recopy that, plus 1/2 log base 3 of x, okay, plus, now it's not just a 1/2 moving to the front, there is a 1/2 and a 3. Now what's your rule with those? Well, an exponent raised to an exponent, you multiply. So this is really 3/2. And that would be how you write your final answer. This is the final. I've expanded everybody, and I am finished. Okay, if you have trouble with that, of course, I can help you in tutorials or through email or text, okay? All right, use the properties to solve an expression. So now we're going to get into the fun stuff. So we got two examples here, okay? One of them's going to be like, what if it's 3 minus log base 2 of, I don't know, maybe it's like a x equals 7, something like that. Okay, so if you have a problem like this, the first thing that I would do is just try to isolate this so that you know what you're up against. So for instance, I'm gonna move the 3 to the other side. Okay, that would be my first step. And then beyond that, I don't like this negative, so I would probably go ahead and change signs. So I would make this side a positive, and then over here this is a 4, and so now it's a negative 4. Okay, cool. And then from here, you're trying to make a number here that's going to equal a negative 4. So it's hard to do this in your head. Instead, I would do that rearranging thing I told you. Okay, so when you get stuck, and I always used to ask my class, they would get to a point and they'd be like, I'm stuck. I'm like, you just told me you were stuck, so what does that mean? When you're stuck, it means rewrite. So we're going to rewrite it using those equations at the top of this page. So that means this is 2 to the negative 4th power is equal to x. And then you just solve and you have x, right? So 2 to the 4th is, what is that, 16? 2 times 2 times 2 times 2? Yeah, that's 16. The negative is going to make it go to the denominator. So it looks like 1/16 will be your answer. Hooray! All right, so let's do another example. What if it doesn't start off as a log, but instead it starts off as just weirdness, you know, like 11 to the x plus 1, and then it's equal to like, I don't know, like negative 5. Okay, so let's say you have something weird going on like this. Okay, the goal, once again, like here we tried to get the log thing isolated. Try to get the exponent isolated. So I would start by dividing both sides by negative 2. And so then you would have 11 to the x plus 1 power equals positive 5/2. Okay, now you're analyzing it, and that is going to be weird, right? Like, I don't know how to do that in my head. I'm not sure what algebra can be done. And so once you feel stuck, rearrange or rewrite. So this is going to be log base 11 of, what number comes next? The 1 across from the equal there. And then it's equal to the exponent. So using my rearranging rules, and I'm just rewriting it. From here, it's called, pick up a calculator. I'm going to type this in right here. I'm going to type this in as log of 5/2 divided by log of 11. And this is going to be some decimal. Notice it's equal to x plus 1. So I'm trying to solve for x. So how do I get that x by itself? Well, I can just subtract 1. And it will leave the x behind. So once I type in this number, I'll get a great decimal, and then I'll subtract 1. And I'm not going to write anymore. Let me just type this in, okay? Log of 5/2 divided by log of 11. And then I get an answer for that. And it's like a 0.38 something something, and then I'm going to subtract 1. So I'm getting x is negative 0.6179, if you want to round out that far. And that's what I'm getting. So beyond this, I know there's more with logs and exponents that you probably remember, and it's one of those things where, let me see if there's any more. Nope, no more. Okay. If you do come to tutorials with me, then of course we will go over stuff like the graphing, maybe some natural log examples, but this is a good just like refresher of logs for you to use for Algebra 2, Pre-Cal, even Calculus. This is just a great like, oh yeah, that's what you do. So hopefully this helped, and good luck trying the practice problems.